Hello everyone, for this video we're going to solve several examples of finding the limits of algebraic functions that we can solve by direct substitution or by factoring. So let's start with our first example. Number 1, the limit of 3x plus 2 as x approaches 1. So we can separate these two terms. So the limit of 3x as x approaches 1 plus the limit of 2 as x approaches 1. So the limit of 3x from our previous knowledge of the theorems of the limits would become 3 times the limit of x as x approaches 1 plus limit of 2 as x approaches 1. So this would be 3 times 1 plus limit of a constant is 2. 3 times 1 is 3 plus 2. So the answer is 5. Or we can solve this by direct substitution. So f of 1 is equal to 3x plus 2. So 3 times 1 plus 2. So we still get the same answer, 5. So negative 1 cubed minus 4 times negative 1 squared plus 5. So negative 1 cubed is negative 1 minus negative 1 squared is positive 1 times 4 is 4 plus 5. So negative 1 minus 4 is negative 5 plus 5 is 0. Another example, the limit of 1 minus 5x over 4x to the fourth plus 3x squared plus 1 as x approaches 1. So by direct substitution, so this would be f is to 1 or equal to 1. So let's substitute 1. So 1 minus 5 times 1 over 4 times 1 to the fourth plus 3 times 1 squared plus 1. 1 minus 5 is negative 4 over 1 to the fourth is 1 times 4 is 4 plus 3 times 1 is 3 plus 1. So our final answer is negative 4 over 8. We can simplify this to negative 1/2. Next, we have the limit of x over x plus 1 as x approaches 2. You may pause this video to do this on your own, and then we'll check. So this will be, by substitution, will be equal to f of 2. So let's substitute 2. So this will be 2 over 2 plus 1. So the answer to this limit is 2/3. Next one, we have the limit of the square root of 2x plus 5 all over 1 minus 3x as x approaches 2. Since we have a denominator and there is a subtraction in the denominator, we want to make sure that by substituting 2, we will not get 0 for our denominator. So by checking, it's not going to be 0. So we can continue by substitution. So f of 2. Okay, so this would be equal to the square root of 2 times 2 plus 5 over all over 1 minus 3 times 2. So the square root of 2 times 2 is 4 plus 5 over 1 minus 6. And square root of 4 plus 5 is square root of 9 over 1 minus 6 is negative 5. And square root of 9 is 3 over negative 5. So the answer is negative 3/5. Our next example is the limit of x squared plus 2x plus 1 all over x plus 1 as x approaches negative 1. So since we have a denominator, then we can check our denominator if it will be equal to 0, and by checking, so it's negative 1 plus 1, indeed it will become 0, so therefore substitution is not going to be our option. So in this case, check our polynomials. So as you can see in our numerator, this is factorable. So we can factor this. So this is limit as x approaches negative 1. So the factor of x squared plus 2x plus 1, this trinomial would be x plus 1 times the binomial x plus 1 over the denominator x plus 1. So as you can see, we can cancel this out. So this will be simplified into the limit as x approaches negative 1, x plus 1. So in this case, now we can substitute f of negative 1. So this would be negative 1 plus 1. So the answer is 0. Our next example is the limit of 3x over x squared plus 2x as x approaches 0. So if we substitute our x equals 0 to our denominator, we'll get 0. So let me show you. So if this would be f of 0, so this would be 3 times 0 over 0 plus 2 times 0. So we'll get an indeterminate answer. So we cannot use direct substitution. So let's manipulate our functions, and we can see that our denominator is factorable. So let's use factoring. So the limit as x approaches 0 would be 3x over, let's factor the denominator, factor out x, so we'll have x times x plus 2. Therefore, we can cancel x and x, so we're left with the limit of 3 over x plus 2 as x approaches 0. Therefore, here we can use substitution now. So this will be f of 0. So let's use here. So this would be 3 over 0 plus 2. So the answer is 3/2. Let's try this one. The limit of x squared plus 3x minus 10 all over x minus 2 as x approaches 2. So we can see right away that our denominator will become 0. So we can't use direct substitution at the moment. So let's do factoring. So how do we factor trinomials like this? If you remember your factoring of trinomials, all you need to do is find the factors of 10, of negative 10, that will give a sum of positive 3. So factors of negative 10 that will give us a sum of negative 3. So let's try negative 5 and positive 2. So negative 5 times positive 2 is negative 10. Let's see if it will give us a positive 3 as a sum. So negative 5 plus positive 2 is negative 3. So not this one. So let's try 5 and negative 2. So 5 and negative 2, 5 times negative 2 is negative 10. Let's try to get the sum if positive 3. So 5 plus negative 2 is positive 3. So therefore, this is our factors. So the limit as x approaches 2, so the factor of our numerator would be x plus 5 times x minus 2 all over x minus 2. So again, we can cancel x minus 2. So we'll have the limit as x approaches 2 would be x plus 5. And then we can use substitution. So this will be f of 2. Let's do it here. So this would be 2 plus 5. So the answer is 7. Let's try this one. The limit of x squared minus 16 all over x minus 4 as x approaches 4. So again, our denominator would be 0 if we substitute 4 to our x. So let's do factoring. So as you can see, we have x squared and 16. So this is what we call the difference of two squares. So the factor would be x, and the square root of 16 is 4. So this is sum and difference of a binomial. And our denominator is x minus 4. Okay, let's write the limit as x approaches 4. Okay, and then we can cancel x minus 4. So we're left with the limit as x approaches 4 of x plus 4. This time we can substitute 4. So this will be 4 plus 4. So our final answer is 8. Okay, our last example, the limit of x squared minus x minus 12 all over x squared plus x minus 20 as x approaches 4. So again, let's factor the trinomial. Let's start with our numerator, the factor of negative 12. That will give us the sum of negative 1. So let's try negative 4 and 3. Is it negative 4 plus 3 is negative 1? Yes. So this is the factor of our numerator. So let's just write that first. The limit as x approaches 4. So numerator is x minus 4 and x plus 3. Now for the denominator, we need factors of negative 20 that will give us a sum of positive 1, the middle term. Okay, so for negative 20, let's say we have negative 5 and 4. Okay, now this will not give us a positive 1 if we add negative 5 and 4. So let's have 5 times negative 4. So 5 plus negative 4 is positive 1. So these are our factors. So for the denominator, we have x plus 5 and x minus 4. And then we can simplify, cancel x minus 4. So we're left with the limit of, as x approaches 4, x plus 3 in the denominator and x plus 5. And then we can use direct substitution. Okay, direct substitution. All right, so this would be 4 plus 3 over 4 plus 5. So this would be 7/9. Thank you.